Focusing on the renewable energy planning app and energy trading platform from the Northwest University. Our supervisor was Dr. Arnold vander Merwe.
And then just an overview of what we will be discussing today. So our presentation has 4 main sections, and we will be going through each of these sections.
So first, we take a look at the surrounding context for our project. So as we all know, South Africa is currently experiencing an energy crisis with rolling blackouts and load shedding. Now, this load shedding causes many businesses and properties to look at alternative energy sources to support the unreliable energy supply. A lot of the businesses use generators, with that leads to more carbon emissions, but we're aiming at advancing net zero, which is one of World Green Building Council's programs aiming for sector decarbonisation. Now, if you take a look here at the graph, for each year of load shedding, you'll see the number of hours of load shedding is increasing. So we need to be looking at long-term solutions. There seems to be no current end in sight. As an example, you can see a growth point at a 424% increase in greenhouse gases emitted due to generator use from load shedding compared to in 2023 compared to 2022, which is a very large increase in the opposite of what we want for advancing net zero. So we've designed a system that will track and monitor and manage the renewable energy system to help reduce emissions, and we're going to be stepping through a life cycle that we'll be covering in more detail what we have done.
If I can ask a big question, how many of us know our daily energy usage and what do we pay for that? So we don't know that. So the first phase of our life cycle is to gather information about the electricity consumption of any property type. So our project was in a residential property, but you can obviously use it for a retail building, anything like that. We used a phase 1 energy meter, but phase 3 can also be used for buildings with higher energy demands. And so we use the IoT energy meter to remotely collect the energy consumption data of the building, and then we save it to the cloud, and in the cloud we analyze the data and create a load profile for the building. So the load profile typically consists of a instantaneous power load profile, and then an energy load profile. So the energy load profile is just power over time, and then we created a time series model to predict the next 24 hours of energy usage, and we used a neural network for that. And we package everything nicely in a web and mobile interface to calculate and analyze or view the analyzed data and predictions. And if I just can highlight the energy meter itself, when it's installed in the distribution box, so we have the essential loads that we want to keep on during a load shedding or a power outage, and then the non-essential loads which can be switched off or controlled if you want to. And then just from the user side of things, so the web interface shows the instantaneous power load profile. So this would typically be a kettle, so 108 or 1800 watts, so it's quite high. And then that is for 30 days, and then the bottom one is the prediction. So this green line represents the prediction of energy usage for the building for 24 hours into the future, and it follows the trend quite closely, and that was done with a neural network.
So from the first phase of the life cycle, we were gathering information for each user's typical electrical usage, but now we're looking at introducing a renewable energy system for this property or business to help them lower their emissions. So in many different property types, it acts as a community. If you look at a retail mall, a business park, like where we are standing right here, or a residential complex, you have a lot of different users of electricity that are collectively a community. They're all on the same grid for this property. And so we looked at installing a renewable energy system for each user in this system. So for example, for Growth Point or the other businesses in this property. But this is not very practical, as each business will have to spend the money, and you have multiple inverters. It's not a very efficient system. But we look at having a single renewable energy system for this community, where each excess energy from this system can be used by each user to help lower their emissions, get them closer to net zero. But this system must be managed and billed. Each user must be billed for the unit energy they're using. It must be tracked. It has to be load control. For example, if it's an evening and the solar panels can only give, let's say, 500 watts, but different users, one user wants to use 300 watts, another user wants to use 600 watts, you have to manage the load so that the grid is not overwhelmed. So they don't use too much that is not there, especially in the case of power outages. So we've designed a trading platform. Here I've got an architecture of the system. We've got a community platform. Now this is the central server for the community. This is where users of electricity interact with via a web user interface to receive electrical information about their status, what their account balance is. I'll show you a nice view later. And you have administrators managing this community by adding users, changing the electrical rates. We've got time of use electrical rates where you can say for a certain time slot, this is the electrical rate during load shedding or not load shedding. So we give a lot of versatility for the admins to manage the community as they want to. We've got a user platform that communicates with the community platform via IoT communication. There's a user platform for each user in the community. The user platform measures the energy being used by each user and bills them. It's also for load control, seeing what their instantaneous power use is. And we've also got, I'm so sorry about this. Let me just put it on. Yeah, I'm so sorry about that. We've got relays that's connected to the load side of the electrical circuit breakers. So this is for switching off portions of a distribution board. If you see a distribution board, you have the many circuit breakers. There's different circuits in the user, but by switching off sections of this, you have a lot of versatility in controlling the load of a user. So we've created a physical test and demonstration setup for this. This was just to test it in a real world environment. As you can see here, we've got ready boards, which are like a distribution board, but we've got sockets for adding loads. We've got user platforms here. We've got community platform. This is just for testing it in the similar real world environment. Now this is a typical dashboard view for a user of the system. You can see here your account balance, your current power usage, what's the current electrical rate you're paying, whether there's load shedding active. Here you've got a nice graph of your current power usage with your energy use. The energy use is the red line. It gives users the option of opting in to receive power during load shedding or opting out. You've given the choice because an admin might want to create a higher electrical rate for if there's load shedding, because then you're using the community's renewable energy system instead of having ESCOM or municipal power as backup. And then, so as a user, you can opt in or opt out. If you opt in and there's load shedding, there's typically a load limit to make sure you don't use too much power to overwhelm the grid and of how much power there is being provided. Now, we have these two phases of the life cycle where we are gathering information and we have an energy trading platform. We can bring these two together to create an integrated functional system. So he's created load profiles. From his load profiles, we can do preemptive load control. So we have a load profile which we can predict what a user is going to be using in the next 24 hours. And then from that, we can do dynamic load control. For example, you have Bob living in a residential complex. He likes having his hot shower at 10 a.m. But the hot shower switches on the geyser, which uses 500 watts. The renewable energy system might not be able to manage this 500 watts. It might be a bit too much. So before Bob takes his hot shower, it already switches off the geyser to make sure that the grid stays stable if there is load shedding. If there isn't load shedding, it doesn't need to be switched off, because then the ESCOM can be used to fulfill this demand. So if I can show the architecture for the integrated system, it's the same architecture of the trading platform, but we've integrated the load profile for each user in the community, where we use the load prediction data as an input to the community platform for dynamic and preemptive load control. Here I've talked about our hybrid system, where we've got ESCOM providing power and we've got the renewable energy system. So the load control and those things are only necessary if ESCOM is not available because there's load shedding. So what we've done is applicable to many areas in South Africa. We have a lot of, I've discussed earlier, the retail malls, business parks, residential complexes, all of these properties which have different users of electricity, which is like a community or a microgrid in it. It helps them lower each of these businesses to lower their reliance on generators, lowering their emissions and helping us achieve net zero for clean and renewable energy.
So what is the benefits of our solution on the economy? So a return on investment for the property. So initially you require high capital for a renewable energy system, but over time it results in long-term cost saving as you don't need as many fossil fuels to run generators during load shedding. And we are also more robust to price increases in electricity tariffs from ESCOM. And we increase the investor confidence as we show commitment to going green and advancing carbon net zero. If you look at ESG, so how does our solution consider the environment? So we improve the building's energy efficiency standards, either rooftop or carport photovoltaics, and we increase the access to clean and distributed renewable energy systems utilizing microgrids. And we help buildings reach carbon net zero by reducing emissions caused by generators. So how does our solution consider society? So we are obviously creating jobs when we install the system, and also the maintenance of the system require some jobs, permanent jobs, and we also can upskill staff. So instead of just having an electrician that installs an energy meter, the electrician can be trained to not only install the meter, but look at data collection and detect anomalies in data collection. So we move everyone towards big data movement, and we also increase the quality of living. So less air and noise pollution. A generator is quite a noisy thing. So that, and then also the access to clean energy. So we create the access to cleaner energy. And then lastly, how does our solution consider governments? So transparency, we have full transparency with the government, we report everything. We also follow the standards of the SABA standards for installing, maintaining, and all the equipment used. And we help the government transition to renewable energy faster instead of having to install large solar and wind farms as we're currently doing in the Western Cape. Each property can have their own system, and it also saves space. So what is the benefits to the core user like growth point? So we have a system size perfectly for each building or each property, and we can control that load. So we have microgrid, which is more reliable than just having access to ESCOM power or a generator. So our life cycle of our system focuses on efficiency, so the correct sizing of the system in the first place, and the precise managing of it, which is done by a microgrid. We have also real-time monitoring and load control, so the predictions update the schedule can be set for to update the predictions, and the versatility. We can install it on any property type, and also the benefits on the bottom line, which is the economic and ESG. And our main thing, advancing net zero by reducing scope 1 emissions, which is the direct emissions caused by a property due to load shedding or in generators. Thank you guys very much.
Thank you.